A very good morning. My name is Alok Shrivastava and you are watching Network Nuts YouTube channel. So this is, guys, really after a long time. There is no doubt about that. So what we are going to learn something very interesting. As you can see, I will be talking about Kubernetes, right? So before we can jump on to okay, let's start creating the cluster. We can use a lot of tools to create the cluster, and we can create pods and containers and all that technical jargon. Just leave it aside. The first thing that we need to learn, that why Kubernetes, what is a microservice, how it is different from a normal monolithic approach of the services. That should be the first point. Instead of just jumping onto the installation part, just leave that thing behind, right? So let's start with the things. And being a sysadmin, let me tell you, one thing is that we are all quarantined, right? So this is 2020. Believe me, guys, till now it's a terrible year, 2020. It is 2020. Sometimes I think it is, if I remove 0, so it is 22, right? So 22 is the port for SSH. Okay, I think something like that. God is doing SSH in our machines and just running rm-rf/root. This is what the God is doing. This is not good. This is not good. You should be like putting up a firewall here to block access. And the firewall comes in terms of isolation, social distancing, wearing the mask. So those things are your firewall, right? So I hope you are all keeping safe and keeping all the precautions. So guys, before we jump onto the Kubernetes, and we will be learning about the different installation patterns like Minikube and doing through kubelets and kubectl, we will be learning a lot about how we can deploy a production ready. Remember the thing I'm talking about. We will be talking and learning a lot about how I can deploy a production ready Kubernetes setup, running a Kubernetes setup using Minikube, running a Kubernetes setup using kubectl on your laptop, using 3 or 4 virtual machines. This is good. There is no doubt about that. This is good. But this is only for learning. You're never going to use that methodology in the production scenarios. So in the production, what are the things that we have to remember? How the setup is done, how it is different from normally they teach at the different levels, just to create a Minikube and or run 3 or 4 VMs, separate VMs using the VirtualBox or VMware workstation. That is just good for learning, not for the production. But before we jump onto it, let's understand what is a microservice. And guys, it has got nothing to do with microwave ovens. Yes. Okay. So let's understand this. Guys, this is right on the screen. So if we just go back some couple of years, so there are 2 approaches how the application need to be deployed or application used to be created. Okay, one more thing. It has got nothing to do with us. These are the developers who have changed the game, and we have to learn it honestly. So initial days, what used to happen, the whole application was being deployed or being created as a single large binary. If you see here, say app1, right? So consider app1 as a banking application. I'll just give you a simple example. So this banking application might be subdivided into certain categories. Some red part is responsible for taking your authentication, right? Then the green part will be responsible for transferring the money in and out, and the yellow part, I think orange or yellow, whatever. I am not color blind, but here I'm confused. Wait, okay. Whatever the color is, I call it orange. So this orange is used to like deliver your statements, right? But the whole application, all 3 components are combined together in the single binary file. It doesn't matter whether you are running a Windows application or a Linux. If it is a Windows, then it's a single exe file. If it is a Linux box, it might be a single RPM, whatever, but it's a single RPM, right? And then we deploy the single RPM on different machines. So because we are expecting a lot of load, So what we have done, we have got three servers, server 1, server 2, server 3, and all the application, the complete application is to be installed on server 1, the complete application again need to be installed on server 2, and so on and so on and so on. So that was easy for us being a sysadmin. We have got a single RPM file or a single exe file. Just do a double click if you are running Windows and install it, and if you are running Linux, either you can use yum or rpm-i to install the package. Everything, all the components are bind together in a single binary file. So that is good, that was good. And how the red code will be talking to the green code and the orange code, it's simple. Try to understand that. It's a single binary. So there will be a simple function call from green to orange, red to orange, red to green, right? Or it is a simple in-memory jump. There is nothing rocket science in it. So that was how the applications used to deliver, application used to create, and application used to deploy. But now the things have changed apart when the cloud has came, right? I'm not supposed to install Photoshop three times on the cloud. Here comes the cloud, here comes a lot of things have changed. Now we have got microservices. Okay, one more thing I wanted to focus here. Now suppose there is a code change in the red one, right? Say Google has changed the captcha. So the banking application need to be modified. These guys need to change or modify the code for the new captcha. Perfect. But so only the team which is responsible for creating the code or maintaining the code for the authentication has the job. They will modify the code, but do you think that only the red team will modify the code and the whole app one can be redeployed again without any coordination with green team and the orange team? Not at all. Even though in this case there is no job of green team, there is no job of orange team, but the red team need to get them involved because the whole binary need to be recompiled and recreated, and then the new version need to be redeployed. So that was a task. That was a task to the developers. What then? What's the change? The change is microservices. So what they are very smart, guys. I'll tell you that these developers, they are very smart. What they have done, they had created independent modules of red code, green code, orange code, and different brown code, violet code, and whatever the color is, right? Now these are modules, or call it microservices. The red code can be deployed independently. The green code can be deployed independently, and yes, they can work together, right? So, and they can be deployed on different machines. So red code here, green code here, orange code here, might be. So one red code is able to self-sustain itself on a server, and the other red code or like the green code is here and the orange code is here. So when a monolithic application, the components are made modular, they are developed in such a way that they can be installed as a single unit on any machine, and further they have the capability to find the green team and the orange team. Think of it. The red code is deployed on server, this server, the server on the top. But now how come it's going to talk to, or how come the green code is going to find, hey, where the red code is, hey, where the orange code is, because I need to work with them. So these codes need to be able to find each other. The green code should be able to find the orange code. The orange code need to be able to find the red code, which might be running on a different server altogether. Here that was not the case. All the components were running on the same server. Try to understand that. Right, so that's the major difference. So how come the green code which is running here will be able to find, hey, where the authentication code is, hey, where the transaction code is? How come? I need something over this cluster, right? Perfect. Just keep that in mind. We need something here. So these are the microservices, means the components are further made modular, they can run independent to each other, and they should have the capability of finding each other via themselves or by some extra services or additional component that we are going to talk about. Right. So how come the green code will find out, hey, where the orange code is? Hey, how come the red code here will find out where the green code is on which machine? I need someone to coordinate. Right? I need someone to orchestrate. That is Kubernetes. Kubernetes is a cluster, or it's a service that runs over and above this. Right. So remember, guys, a lot of you might have done RSC, or you are already certified, or you are already working on cloud, things like Azure and DevOps. But believe me, guys, the application scenarios is changing, and one of the important tasks of a sysadmin is to deploy the application. So till now, if if the application is coming up in a monolithic manner, you are able to simply deploy it using yum install or any other application, because it's a single binary. Everything is within the same binary, right? All the codes. But what if the application comes to you in microservices? How I am going to deploy it? You need knowledge of Docker. You need knowledge of Kubernetes. So this particular, what do you call it? The playlist, right? The Kubernetes playlist. I presume you have, earlier you are comfortable working with Docker. So I'm not going to touch Docker here. If you wanted to learn more about the Docker, just feel free to find the Docker playlist and check the videos there. Right. So how come these components will be able to talk to each other? Here comes Kubernetes over and above your cluster. I'll explain you how. Right. So containers are the main things, like where the application is deployed, and the application is distributed application. As I have told you, certain part is running on a different server, a certain part is running on a altogether different server. So a lot of things need to be changed, guys. I cannot deploy a monolithic application on Kubernetes. I cannot do that. So it starts from the ground zero. Ground zero means the developer need to write the clean code. The coding need to be changed. So that's not my cup of tea. That will be done by the developer. No problem. I'm just telling you. Right. So developer need to write the clean code. Developer need to write the code which adhere to the microservices principle. And then finally, my job will be to understand how the Kubernetes works and how I can deploy that. So let's take it one by one. Code level. It is important for the developers to grow, developers to write the clean code. It is important for developers to write the code in a microservice manner. They cannot write the code they used to write it some 5 years ago, 6 years ago, right? So they have to give the right amount of automation. They need to improve the code quality. They need to change. They need to write the code, the artifact, so that they can be deployed as a microservices. So that is to be done by developer, need not to worry. Domain design is also, that means what? Domain driven design is my whole office should be coming virtual, right? How we are functioning physically, the same model I need to replicate. Microservice architecture. The developer need to write the code in such a way that it should be able to scale, should be able to change, should be able to work as per the microservices architecture. So that is again to be done by the developers, not us. Containers is the main thing, right? So now the application, the microservices will be running in something known as a containers. You already know this. You are all champion, guys, right? So creating the modular reusable container, that's the good cloud native application. Remember one thing. Wherever you heard things like cloud native application, web-based application, microservices, that means you have Kubernetes somewhere, you have containers somewhere, pod somewhere, which is maintaining it. So Kubernetes is the most important open source cloud, the native platform which is available today, right? So That is why we need to learn Kubernetes, so that we should be able to deploy the applications which are coming to us in a microservice manner. So, so how can I do this? The answer is containers. As the name says, containers. Many people think, why containers? Hey, container, think of it as a container. So that application holds everything which is necessary for it to run. All the library files, the dependencies, and everything is being held inside the container. Right. So I need not to depend on the operating system to give me those things. So containers, guys, are the building blocks for the Kubernetes based cloud native applications. Think of it as the classes or objects in Java. So we need to understand that before we jump onto it. So remember this underlying thing, low level thing, it is containers. The high level thing, which is maintaining the cluster of container, is Kubernetes. And one more thing, I would like to give a simple example here. How it is done is you need to go to the second video. I'll just catch you up in the second video. I'll be giving you another example to make the things very clear. Come on, let's move to the second video.